What if I told you there's a place in the universe where nothing exists? Picture mapping the cosmos, charting thousands of galaxies. And then suddenly, your map goes blank. Not because you missed something, not because your equipment failed, but because there's nothing there. In 1981, astronomer Robert Kirshner and his team were doing exactly this, measuring how fast galaxies were moving away from Earth to build a 3D map of the cosmos. And that's when they found it. A hole. A massive spherical region of space 330 million light-years across. So big that our entire Milky Way could fit inside it billions of times over. They called it the Boötes Void. Some just call it the Great Nothing. And here's the strangest part. It shouldn't be empty, but it almost is. The discovery. Let's go back to what Kirshner's team was expecting. In a region that size, you'd normally find around 2,000 galaxies. That's the pattern everywhere else in the universe. Galaxies clustering together, forming this giant cosmic web of filaments and superclusters. But in the Boötes Void, they found 60. Only 60 galaxies. In a space where there should be thousands. And those 60? They're all squeezed into a strange tube-shaped formation running through the center of the void, like they're huddling together in the emptiness. The void sits 700 million light-years from Earth, near the constellation Boötes, the herdsman pushing the plow around the North Star. Astronomer Greg Aldring put it perfectly. If the Milky Way had been in the center of the Boötes Void, we wouldn't have known there were other galaxies until the 1960s. Think about that. We discovered other galaxies in the 1920s. But if we'd been born in the void, we would have thought we were alone in the universe for 40 more years. That's how empty it is. How voids form. So what creates something like this? The answer takes us back to the beginning, right after the Big Bang. In those early moments, all the matter in the universe was packed together. At first, it looked pretty uniform, just a hot, dense soup of particles. But then, quantum fluctuations kicked in. Tiny, random variations in density. Some areas became slightly more packed. And because they had more matter, they had stronger gravity. So they pulled in even more matter from nearby regions. The denser areas got denser. The emptier areas got emptier. As the universe expanded, these small differences grew into massive structures, the cosmic web we see today. Galaxies gathered along filaments like beads on a string. Where filaments crossed, massive clusters formed. And in between, voids. These aren't pockets of nothing in the traditional sense. They're more like bubbles in foam, gaps left behind as matter rushes toward regions with stronger gravity. Voids make up about 80% of the observable universe. Most span 30 to 300 million light-years across. The Boötes Void is one of the largest, a supervoid. Scientists think it formed when smaller voids merged together over billions of years, which might explain why those 60 galaxies are arranged in that tube shape. They could mark the boundaries where older voids collided. What's actually in there? Here's what makes the void fascinating, not terrifying. It's not a black hole. It's not a dark nebula blocking our view. We can see through it just fine. It's just statistically weird. Those 60 galaxies that are there, they're real, observable, and some are even within reach of amateur telescopes. Faint, yes, magnitude 15 or 16. But they're there. And the void itself isn't pulling things in. It's doing the opposite. Because there's so little matter inside, there's barely any gravity. And where there's no gravity, dark energy takes over. That mysterious force pushing the universe apart. So Galaxies near the void's edge are actually moving away from it, escaping toward denser regions of space. The void is growing. Why it matters. Studying voids, like Boötes, helps us understand dark energy and how the universe has evolved since the Big Bang. By measuring how voids expand over time, scientists can track how fast the universe itself is accelerating. Voids are also perfect laboratories for studying neutrinos, tiny particles that zip through space without interacting with much. In the emptiness of a void, they travel freely, giving us cleaner data than we'd get in crowded regions. Today, missions like the Dark Energy Survey and the Euclid satellite are mapping these structures in unprecedented detail, comparing what we see with computer simulations of how the universe should look. And so far, the Boötes Void fits our models. It's strange, but not impossible. It's a reminder that the universe isn't uniform. It's lumpy, uneven, and full of surprises. Some places are packed with galaxies. Others are almost completely empty. And somewhere out there, 700 million light-years away, floats one of the largest stretches of nothingness we've ever found. The Boötes Void is proof that even emptiness has a story to tell. If you're into discoveries that make you rethink how the universe is put together, hit subscribe. Because we're just getting started exploring the weird, empty, and incredible corners of space.